Welcome to The Explainer. If you're swimming in the Azure DevOps pool, you've definitely heard of AKS, Maven, and SonarQube. They are, quite literally, the foundation of how modern apps get built and delivered. So today, we're going to break down the kind of questions you'd face in a real-world tech interview, pulling insights directly from an expert Q&A session.
We're going to walk through the whole journey, right? First, we'll get our hands dirty and actually deploy a Kubernetes cluster. Then we'll peek inside to see how it's built, figure out all the networking stuff, and then talk about how to keep it running day to day. And finally, we'll connect it all to the build pipeline with the tools that actually craft and check our code.
All right, let's jump right in. We're starting at ground zero. How do you take an idea and turn it into a living, breathing Kubernetes cluster in Azure? This is step one.
So you get the ticket. We need a new AKS cluster. What's the right way to do it in a professional shop? I mean, yeah, you could go click around in the Azure portal, but that's just not how it's done in the real world.
The answer, and really the only answer, is automation. We're talking infrastructure as code, and the tool of choice is almost always Terraform. You write code that defines everything, the virtual network, the subnets, the cluster itself. Why? Because it makes your deployments consistent and, more importantly, repeatable. Every single time. No, oops, I forgot a setting moments.
Okay, so the cluster exists. Great. But right now, it's basically an empty box. It needs to pull your application's container images from a registry to actually do anything. So how does it get permission to do that without you scattering passwords and secret keys all over the place? Because that's a huge security no-no. And the solution is really slick. It's called a managed identity. The best way to think about it is like giving your entire AKS cluster its own corporate ID badge. Azure manages this identity for you, and you just grant that badge the specific permissions it needs, like you're allowed to read from this container registry. No passwords, no manual secrets to worry about. It's clean and super secure.
So, our cluster is up and has its own identity. Now let's pop the hood and take a look at the core building blocks that you'll be working with every day.
When you get right down to it, an AKS cluster is really just a bunch of virtual machines, or nodes, working together. And we organize these nodes into what are called node pools. A node pool is just a group of identical VMs, all with the same size and configuration, ready to run your apps. And this is a really critical design concept in AKS. You don't just have one big blob of nodes. You split them into two types. System node pools are reserved just for the essential Kubernetes services, the brains of the operation. And then you have user node pools, which is where your actual applications live. This separation is key because it protects the cluster's core functions from your own application code. It's a firewall between their stuff and your stuff. Okay, we've got the basic structure down. Now, let's talk about how everything connects. How do these little application containers, or pods, talk to each other and to the outside world? This is all about networking and identity.
This is one of those fundamental decisions you have to make right at the start. When your application pod spins up, it needs an IP address. But where does it get it from? How you answer this question has huge implications for performance and what you can do later on.
You really have two main choices here. Kubernetes is the simpler, more basic option. But for any serious enterprise-level setup, you're going to use Azure CNI. The big deal with CNI is that every single pod gets its own real IP address directly from your Azure virtual network. This makes them first-class citizens on the network, which means better performance, and it unlocks powerful tools like Azure Network Policies for super granular security rules.
So remember how we gave the whole cluster an ID badge? Well, sometimes a single application needs its own special permissions. That's where Azure Pod Identity comes in. It lets you assign a specific managed identity directly to a pod or a group of pods. So your one little microservice can have permission to talk to a specific database and nobody else can. It's all about that fine-grained, least privileged security.
So, the cluster's built, networking is sorted, apps are running, we're done, right? Not even close. Now comes the hard part, keeping the lights on. Let's talk about the day-to-day work of managing the cluster.
The cluster upgrade. It's something you have to do, but it can be a little nerve-wracking. The number one fear is always downtime. You just can't take your applications offline. So how does AKS handle this gracefully?
It's actually a pretty elegant process, like a carefully choreographed dance. First, AKS brings in a brand new, fresh node with the updated software version. Then, it picks one of the old nodes and basically puts up a closed for business sign. That's called cordoning.
Next, it gently moves all the application pods off that old node and onto the new one. That's draining. Only when the old node is completely empty does AKS delete it, and it just repeats this, one node at a time, until the entire cluster is upgraded, all with zero interruption to your users.
Okay, let's switch gears a bit. We've talked a lot about the infrastructure. Now let's talk about the code that actually runs on it. How do we get that code from a developer's laptop, check it for quality, and package it up ready for deployment? It's time to talk toolchain.
When it comes to the world of Java, and trust me, it's a massive world, there's a very established, very standard way of doing things. And the tool that orchestrates this whole process is usually Maven.
Maven gives everyone a common language through its build lifecycle. It's a series of phases that run in order every time. You start with clean to get a fresh slate. Then you compile the code, run all the unit tests, package it up into a deployable file, and finally deploy it to a shared repository where your cluster can grab it. It's predictable, it's repeatable, it just works.
So the code builds. That's great. But is the code any good? Is it secure? Does it have obvious bugs? Is it a tangled mess that'll be impossible to maintain? We need an automated way to answer these questions.
And that's exactly what Static Application Security Testing, or SAST, is for. A tool like SonarQube is basically an automated expert code reviewer. It scans your source code without even running it and looks for thousands of known security vulnerabilities, bugs, and things called code smells, which are just signs of messy, low-quality code.
Finding problems is one thing, but how do you actually stop bad code from getting out? That's the job of the quality gate. Think of it as a bouncer for your pipeline. You set the rules, like 0 new critical vulnerabilities allowed, or test coverage must be over 80%. If a developer tries to commit code that breaks those rules, the quality gate slams shut, the build fails, and that code never sees the light of day. It's your automated line of defense.
So let's take a step back. We've automated how we build infrastructure. We've automated how we operate our clusters. We've automated how we build and check our code. This foundation of automation is the heart of modern DevOps. And once you have it, it lets you ask the really interesting question. Now that the basics are handled, where do we go next to get even better, faster, and more secure? Thanks for joining this explainer.